So our next group took a fast-paced card game and decided to bring it to the web so that fans of the game could play even when they're in different time zones. They were faced with the challenge of managing and keeping lots of complex and constantly changing data that deals with the game up to date and in sync across multiple players. But they were able to create a really seamless experience that feels just like sitting at a card table with a bunch of your friends. So the next group, I'll let them tell you a little bit more about their project. Here we have NertzIO.
Thanks, Jeff, and welcome everyone to NertzIO. My name is Jessica Freasier, and my fellow awesome teammates for this project are Derrick Beining and Sara Helba. We are very excited to present you with NertzIO, web app version of the fast-paced real-time multiplayer card game Nertz. For those of you who are sadly unfamiliar with this game, it's a hybrid of Solitaire and Speed, where players race to get their cards onto the field before someone's Nertz pile goes down to zero. Unfortunately, the in-person version of Nertz has its limitations. For example, Derrick's wife often wants to play Nertz, but it can be a hassle to get enough players to make the game fun. By bringing the game online, we improve the marriage of Derrick and his wife. These two and other lovers of Nertz now have a way to play the game with friends at home in their pajamas. The real-time updates within this app make it a compelling option for these folks. The core technologies and libraries that we use for this app include React, Firebase, Redux, and React D&D. We use Firebase authentication for identity and access management, and Firebase database for data persistence and real-time updating across all clients. I will now hand off to Derrick to showcase our app and elaborate further on how we use these technologies.
Thanks, Jessica. Here you can see NertzIO in action. The user can choose whom to play with when entering a game by using a shared game key. When the game starts, each user plays by moving their cards between their stacks in the shared field, seeing real-time updates from other users during gameplay. Each player can see the same data simultaneously as all players make their moves. While the drag and drop functionality looks effortless to use, it wasn't so easy to implement. We used the React drag and drop library in order to leverage the browser's built-in drag and drop utilities, but with a React-oriented API that allowed us to decouple our components from all of the event handling logic. With React D&D, we were able to define our card components as drag sources and our stack components as drop targets, and then provide minimal logic for validating what cards could be dropped where, and what to do with the data in the drag source when successfully dropped on a target. Figuring out how to move multiple cards was also a challenge. In order to include multiple cards as a single drag source, we had to implement a recursive React component that was itself a drag source. Each recursive call renders a drag source nested within another drag source. And the effect of this is that if you drag a parent component, you drag its children too. After all this dragging and dropping, one player is going to eventually deplete their Nertz pile, enabling them to call Nertz and end the round, halting the game and displaying everyone's scores. I'm now going to hand off to Sara, who's going to talk about our application's architecture.
Thanks, Derrick. We utilized React, Redux, and React D&D to build and support our user interface and integrated this with Firebase. Maintaining React Redux's one-way data flow philosophy, we leveraged Firebase as a single source of truth for our app. User drag and drop interactions trigger updates to Firebase, which broadcasts those updates to connected clients in the game. Firebase's client-side event listeners then push those updates to all users' Redux stores for rendering. Every move is able to be shared with all clients immediately, given this real-time source of truth in Firebase. The same functionality could be accomplished using a typical relational database like our trusty Postgres in conjunction with sockets and Node. But in the interest of achieving the lowest latency solution, we decided to use Firebase's document-based NoSQL database rather than a relational one. Now that you've heard about what a neat app this is, we have no doubt that you're itching to try it out for yourselves. Please feel free to do so at nertzio.herokuapp.com. We've learned a lot during our journey at FullStack, and we really appreciate the opportunity that we were afforded to fast-track our development as developers. We enjoyed working together on this project and learned a lot from each other. We hope that you get as much out of NertzIO as we've been able to. Thank you.
All right. Quick reminder on if you would like to vote for Nertz, like the pinned comment right now. They should see on the Facebook live stream. I thought it was really done really well. I've always loved two things: real time and drag and drop on the web. I feel like it's.
I've also loved a third thing, which is the game speed.
Yeah.
It seems to be a lot more fun version of that.
Yeah, this one's a lot of fun too. It's one of those games where there's just so much going on. It feels
Speed is the
chaotic.
name of the game. I thought speed was. They were saying like solitaire and like the drug speed, but no, this is.
Really?
I did not know there was a game called Speed.
Is that you realize we're live right now?
Okay.
There's no 5-minute delay.
There's no speed at full stack or grasshopper, so.